Assalamualaikum and good morning, everyone. Hope everyone is doing well on this Wednesday morning. Without further ado, we will get started with the first speaker of today. So the first speaker of today is Professor Puteri Shafinaz Abdul Rahman. And before we proceed, please allow me to give a brief biography of her background. Professor Dr. Puteri Shafinaz Abdul Rahman is a molecular biologist and proteomics scientist at the Department of Molecular Medicine, Faculty of Medicine, University Malaya. She is a founding member and current head of the University Malaya Center for Proteomic Research. Her research focuses on comparative proteomics using mass spectrometry to investigate how protein signatures reflect disease states, therapeutic responses, and biological adaptation. Her work spans cancer biomarker discovery, natural product mechanisms, and the molecular profiling of human milk. She has led several pioneering studies on the milk fat globule membrane and temporal changes in the human milk proteome, with current projects examining how maternal metabolic conditions, including gestational diabetes mellitus, influence milk composition and early life immunity. Her research aims to deepen understanding of the bioactive role of milk in shaping human development and health trajectories. Today, her presentation title is Human Breast Milk as a Biologically Intelligent System, a proteomics exploration from evolution to maternal health. So without further ado, please welcome Professor Puteri Shafinaz Abdul Rahman. The floor is yours.
Thank you very much, Megat, for the kind introduction. Okay, let me just share my slide, yeah. Assalamualaikum and a very good morning. And thank you for the opportunity to share this session with you. So today I'd like to invite you to look at breast milk from a slightly different perspective, not simply as nutrition, but as a biologically intelligent system. So the title of this talk actually reflects a journey moving from evolutionary design to maternal health, and how proteomics actually allow us to better understand the hidden biology of human milk. So when we talk about breast milk in clinical settings, we often focus on calories, macronutrients, or feeding volume. Okay. However, breast milk is actually far more than just a source of nutrient. It contains a wide range of bioactive molecules and regulatory molecules as well, okay, that actively communicate with the infant's body. And rather than being static, milk functions as a dynamic biological system that continuously supports growth, immunity, and development. So when I use the term biologically intelligent, so I'm actually not suggesting consciousness, but rather the adaptability. So milk responds to the developmental stage of the infant, and it can actually change over time, and it reflects the mother's physiological state. So in other words, it is responsive to context, both infant-driven and also maternal-driven, which is actually a hallmark of biological intelligence. So as Megat mentioned just now, I'm actually a proteomic scientist and a molecular biologist. So why is it that I choose to focus on proteins in my research? Well, mainly because proteins are where the biological function happens. So while fats and carbohydrate provides energy, proteins act as immune defenders, okay, signaling molecules, enzymes, and growth regulators. So many milk proteins are not there just to give nourishment in the traditional sense, but to help regulate infants' physiology, shaping their immune responses, metabolism, and also tissue development. Okay, so using proteomics actually allows the milk proteins. It is actually very ideal that for us to actually use it for exploration. And proteomics actually allows us to understand complex biological interaction that is actually happening in the sample itself. So for those who are not familiar with proteomics, okay, so what is actually proteomics? It's a study that allows us to actually look into proteins and essentially allowing us to see many proteins at the same time, meaning that we will be able to profile proteins simultaneously rather than studying them one by one. Okay, so that's studying them one by one is like more of the conventional method. Okay, and importantly, proteomics allows us to capture not just which proteins are being present, okay, meaning that we look at the expression of the protein, but it also allows us to see how they are modified. Okay, so this would be like certain tools in proteomics can be utilized to look into post-translational modification and also potentially how these proteins function. So this would be when we actually do functional analysis or functional network analysis on the data that we obtain. And usually this is actually using, all this is actually using mass spectrometry based platform. Okay, so using this mass spec platforms allows or makes it possible for us to actually profile the complexity that are found in biological fluids such as human milk. So what proteomics reveal is that milk contains a level of biological complexity that cannot be appreciated through conventional nutritional analysis. We begin to see immune factors, growth regulators, enzymes, and signaling proteins distributed across the different milk fractions. Okay, so this functional diversity helps explain why breast milk plays such a critical role in early life programming and health outcomes. And to understand why human milk is so unique, it actually it's good for us to actually step back and look at milk through an evolutionary lens. Okay, so this is among one of the first early works that I was involved in my lab when we actually started doing work on human milk. Yeah, so milk is actually species specific by design, shaped by millions of years of evolution to meet the survival needs of each offspring. So in our study, we actually compared human milk with milk from other mammals such as bovine and caprine, these two species, to allow us to look into and also appreciate how differences in growth rates, immune maturity, and developmental timelines are reflected in the milk composition. And our proteomics comparison consistently show that human milk is particularly enriched in, they are particularly enriched in proteins that are involved in immune regulation, okay, neurodevelopment, and also metabolic control. Okay. And another, in this particular study, we also look closer into a fraction of human milk, which is actually isolated from the cream layer of milk, okay? And this is called the milk fat globule membrane, or MFGM in short, okay? And what we found is that the MFGM carries a diverse array of bioactive proteins. And these proteins are not just structural, but they also actively participate in immune defense, gut maturation, and also brain development. So from a clinical perspective, okay, this species specificity has an important implication, okay? So while infant formula can be formulated either from bovine milk or caprine milk to approximate the nutritional content of human milk, it cannot actually fully replicate the biological activity that I've just elaborated just now. Many of the immune and signaling proteins found in human milk have no direct equivalence in bovine or caprine milk. Okay? So this actually helps explain why breastfeeding continues to confer health benefits beyond basic nutrition, particularly in early immune development. Another key feature of biological intelligence is the adaptability over time. Yeah? Milk composition is not fixed, after the early postpartum period. Instead, it continues to actually change as the infant grows, and reflecting the shifting nutritional, immunological, and also developmental requirements. Okay? So this actually challenges the common assumption that the value of breast milk declines with time. So we have a project that is almost completing right now, where we actually examine milk longitudinally, okay, over a 24 months period. Okay? And what we see, there is actually distinct functional patterns that emerge. And when we look into it, we see that in the earlier stages of lactation, the proteins tend to be enriched, or the milk is actually enriched in proteins that support immune protection and rapid growth. Okay, and as the lactation actually progresses, there is actually a gradual shift towards proteins that are involved in metabolism, tissue maintenance, and longer term developmental processes. So I guess what we want to say is that more importantly is that the fact that milk actually remains biologically active throughout this entire period. Yeah, so this is actually up to 2 years of the baby's age. Rather than thinking about milk, milk changes as gains or losses, it is actually more helpful for us actually to think in terms of functional prioritization. Across lactation, the milk proteome supports immune modulation. Okay? It supports metabolic regulation and also skeletal and tissue development. Okay? And these shifts reflects the changing physiological priorities of the growing child. So taken together, okay, the observation that we have so far highlight why extended breastfeeding can continue to offer biological benefits well beyond infancy. Okay? Milk does not become redundant. Instead, it actually adapts to provide age-appropriate support. Okay? So from clinical and also public health perspective, this actually reinforce the importance of informed breastfeeding guidance that recognizes the ongoing biological value of human milk. So up to this point, our research have focused largely on the infant side of the equation, okay, which is the evolutionary needs and developmental stages. But the next step in our research looks also in terms of milk as the product of maternal biology. Okay? So we know that mother's physiological state, including the metabolic and inflammatory status, actually directly shapes the milk composition. So in sort of like our kind of language would be like there will be changes or alteration in the milk proteome. Okay, so in this way, milk actually becomes a biological communication channel between the mother and the infant, and it carries signals that extend beyond nutrition. So in our work, we focus on gestational diabetes mellitus, okay, or GDM, which is actually one of the most common metabolic conditions affecting pregnancy worldwide. Okay? Its effect on maternal and fetal health are well documented, ranging from altered glucose metabolism and to increase long-term metabolic risk for both mother and child. What is actually less understood is how this metabolic disruption may influence the breast milk composition after birth. So why do we actually choose to study GDM through milk? Well, because breast milk actually represents a critical postnatal exposure pathway. Okay? It delivers not only nutrients, but also bioactive proteins, cytokines, and metabolites. Okay? And this can interact directly with the infant's developing immune and also metabolic systems. Okay, so if the maternal metabolic conditions such as GBM alter these signals, milk may serve as an important mediator of early life programming. So this actually leads to several important questions that are currently being explored in the project that we are conducting. Okay, this is actually an FRGS project that we have started in 2024 and it's still ongoing. Okay, so some of the questions are, does gestational diabetes actually alter the bioactivity of milk? Okay, are the immune-related and also metabolic signaling pathways being modified? Okay, and if so, what might it mean for the infant's development, particularly in the early months of life when the nervous system are still plastic? So these questions become even more critical when we consider preterm infants. Okay, compared to term babies, preterm infants actually have immature immune, gastrointestinal, and also metabolic systems, which actually makes them particularly vulnerable during early life. So for these infants, breast milk is simply not a source of nutrient, but it's also a primary source of immune protection, anti-inflammatory signals, and developmental cues. Because preterm infants rely so heavily on milk-derived bioactive factors, any changes in milk composition, whether driven by maternal metabolic status or other physiological condition, may have amplified consequences. So this is actually why milk quality and not just milk volume is clinically important consideration in neonatal and also pediatric care. So before we move to some of the final take-home messages, maybe it's helpful for us to actually step back a little and integrate this story. Okay, so what we know from what I mentioned just now is that human milk is shaped by evolutionary design, meaning that it is species specific and optimized for human infant. Okay, and at the same time, it adapts dynamically across lactation to match the changing needs of the growing child. And it also reflects maternal physiology, including metabolic health. So when these dimensions are viewed together, okay, meaning evolution, time, and maternal health, they clearly position breast milk as a biologically intelligent system, one that is responsive to context, environment, and biological needs. So from a clinical perspective, there are few key messages to take away. First would be breast milk should be viewed as an active biological system, not just a nutritional product. Okay? And second is that maternal health does not stop influencing the child just at delivery. Okay, maternal physiology continues to shape the infant's early environment through milk. And finally, breastfeeding itself can be understood as an early life intervention, one that has the potential to influence immune, metabolic, and developmental trajectories. And the use of proteomics as tools helps us understand milk because it allows us to actually see the layers of biological regulation that otherwise is invisible. Okay, it helps to identify not only which proteins are present, how they interact and respond to different physiological contexts, but it also opens doors to more personalized maternal and infant care, and also provides a stronger evidence base for future nutritional and clinical strategies. Taken together, the evidence increasingly points to breast milk as an adaptive and responsive system, one that adjusts to evolutionary demands, developmental stages, and maternal health. Okay, and proteomics gives us the tool to begin decoding this biological intelligence, helping us move beyond what milk contains to what milk does. So I'll end my talk here, and I thank you for your attention. I hope this session has offered a useful perspective on how proteomics is actually reshaping the way we think about breast milk and maternal infant health. So I'll be happy to take any questions or hear your thoughts. Thank you.
Thank you very much, Professor Puteri, for the very insightful and highlights on the use of high-resolution platform of proteomics to actually investigate the content and the protein biology of human breast milk. We'll now proceed with the Q&A session. So I will now open the floor for anyone who has questions for Professor Puteri, but you can also put in your questions in the webinar chat, and I will go through it. If there is no question, I might start the session first. It is a very interesting talk, and I'm wondering, my first question would be that, is there any environmental factors that could influence the content of the breast milk? For example, if could postpartum depression can influence breast milk content production?
Okay, thank you, Megat, for the question. Yeah. Yes. In terms of environmental factors, yeah, it actually does gives effect to actually, well, one thing would be milk composition, of course, yeah. Because as you say, if it's like postpartum depression, or even sort of like when even as simple as environmental conditions where changes in weather, if it's been too hot and things like that, can actually change the composition of milk. Okay. Okay, I'll use the weather sort of like a simple kind of explanation first. Even as in terms of weather, if it's too hot, you actually see that the content of milk actually changes. It's so intelligent that it changes. It becomes not to say it's diluted, but the content of water becomes higher. Okay. And the sort of like proteins and carbohydrates, and that is still present, but the water content will be higher to actually supply the infant with sort of like, because I mean, they don't drink water in cups and things like that with us. So the mother's milk is actually intelligent enough to sense these changes in environment and adapts it accordingly. Yeah. And yes, in terms of even hormone signals would be also secreted in milk and actually can be passed on to the infant. So I would say in terms of postpartum depression or even sort of like, other conditions, yes, this may sort of like, not to say alter, but it does change the composition of milk, or some factors will be released in milk. Yeah.
And I guess it relates back to what you were saying about the adaptation over time. So
Yeah.
the environmental factors could also influence how the content changes, isn't it? So my next question would be that you were saying just now that over across the lactation stages, there will be changes, adaptability over time during the postpartum period. Is there a specific signal in the maternal biological body that indicates the shift? Or is it like specific stages, or like month one to month three, this is the production, month three, month four to month six? Or is it like very, yeah.
Yeah. So what we actually saw is that it's not because we are so used to sort of like the child's developmental stage, as in like, the first 6 months, the sort of like up to 1 year old, and then like when they are 1 to 2 years old. So when we sort of like were doing the analysis, so that's the mindset that we have. And then we were a bit thrown off because it was like what we see is that of course the first few months you'll see a lot of those immune proteins that are being expressed, and well, naturally we know that that is actually the time that is needed because the baby's immune system is just developing, okay, becoming mature. But there's actually a sort of like a little bit of graduation in terms of how the protein changes. It's actually up to 18 months that all the other proteins that are contributing to the growth development, bone development, things like that, are actually sort of like being expressed. So of course, because in our mind it's up to 1 year, but it's actually up to 1.5 year. But of course, it's logic, yeah, because the child is actually growing up. So there shouldn't be sort of like this set timelines. So it's actually very, how to say, it's a gradual thing, yeah. But what we know is that um, even to up to 2 years, the milk is still nutritious and contain all the bioactive factors. Yeah, so sort of like the drive for us to actually do this research is because the rate of breastfeeding, it is actually WHO policy to actually encourage breastfeeding to up to 2 years. Yeah, but of course, we understand sort of like in the world where mothers are also actually working and things like that, sometimes the push to actually breastfeed up to 2 years with all those difficulties and things like that may not be something that is, possible. But our sort of like intention is also to have this kind of information available for mothers, yeah, to probably give them sort of like an aim to, go on and proceed up to 2 years to breastfeed their child. Yeah.
Cool. Thank you very much, Prof. Puteri. There's two questions in the chat right now. I'll just go to the first one first. So from Lucy Lum, thank you, Prof. Puteri, for the insightful lecture. Is there any difference in biological factors between express BM and direct latching?
Okay. Um, okay. Yes, actually there is. Because there are actually studies that looks into this. So I've actually just sort of like read the literature. Yes, there are actually difference in biological factor when milk is actually being expressed, meaning through palms and things like that, and compared to direct latching. Okay. Main factor is like when you actually you are directly latching onto the baby. Okay, there's actually also a two-way connection between you and the baby itself. Okay, and it's like you have all the different emotional cues, and also sort of like that there'll be all these hormones that are affecting you when you actually feed the baby. Okay, happy hormones and things like that, and all this actually um allows sort of like the biological factors to actually be secreted into to the baby through the milk. Okay, so it's slightly different if you actually look at the situation when the mother is actually expressing the milk. Okay, so of course sometimes mother would be away from, because they're working, they'll be away from the baby. Okay, so of course this would still allow the mother to express the milk, but maybe the content will be slightly different compared to when they're actually direct latching the babies. Yeah.
Thank you very much, Prof. Puteri. I hope that answered Prof. Lucy Lum's question. We'll finish up with one last question from Dr. Yap House. Dr. Yap, thank you, Prof. Puteri. For babies who are fed formula fully during the first month of life, but was later fully breastfed, how does this impact the baby in the long run?
Okay, right. Thank you for the question. Okay, so babies who are fed formula fully during the first month, okay, of life, but later on they're fully breastfed. Okay, so I would I guess okay, this is I would think I would have to answer this based on sort of like personal opinion. So for me, actually, I would not think that, there's effect that will harm the baby, even if, let's say, they're not fully uh fed, they're fed formula in the first month of life. Um, of course, yes, we do recognize the importance of breastfeeding at the very early stages of life, okay? But the nutritional content of milk and also the bioactive factors that are found in milk throughout the early part of feeding, which is like maybe up to 3 months or 6 months, and also up to 2 years, they are still um, how we say that they are still functional, and it allows the baby to actually obtain the the uh, sorry, I'm a bit lost in terms of the words that I want to use. So they can actually compensate for the sort of like the part where they actually lost in the first month of life. So to me, it's like even not having that bit in the early parts of life, it's still when the baby is actually getting breast milk following that, they still obtain the goodness of breast milk for them to develop their immune system, for them to develop their gut system, the neurodevelopmental system, and all the others. Yeah.
Yeah, thank you very much, Prof. Puteri. Hopefully that's answered Dr. Yap's question.
Mhm.
And as it's already 8:33, if there is no more question, thank you very much, Prof. Puteri, for the very
Thank you.
interesting and insightful
Yeah, it's
talk
my
today.
pleasure.
And I will now pass to the next moderator for the next session. Thank you.